Hello again. This is the second video of section 1.5. We're going to start with example 5 on page 26 of the class notes notebook. Let's go ahead and read this example. It says a person's heart mass is known to be proportional to their body mass. There's that word that we just went over in the last video, proportional, which is defined in a box on the top of this page, which says Q is directly proportional to T if Q equals KT. Again, I got this at the top of the page, the very first line, the definition. And by the way, you do not need the word directly. You could just say Q is proportional, which is what this one does. And the second line on this page says where K is a constant, called the constant of proportionality. So in this case, it says here a person's heart mass, that would be the Q, is known to be directly proportional to, this would be the T. So in our case, I'm just going to say Q is equal to KT. And I'm going to go ahead and try to find the K. Again, where Q is a person's heart mass and T is their body mass. So Q is a person's heart mass right here, and T is the person's body mass. So part A person with body mass 70. So that is their body mass. So that's 70 kilograms. I say kg for kilograms. Has a heart mass of 0.42 kilograms. I don't know if they could call it HG. Do not know the shortcut for that one. So we can go ahead and find the constant. What's great about proportionality, these units do not even need to be the same. So we can say here that Q is 70. Q is 0.42. K we don't know. T is the 70. So that would mean 70K is equal to 0.42. We can solve for K by dividing both sides by 70. So K would equal whatever that is on our calculator, 0.42 divided by 70. 0.006. That is part A. And that is the answer. Now, you could also have looked at this equation instead and did a shortcut. So you could have also said, or Q over T, and it goes directly to what the K is. So notice how the Q is 0.42, the T is the 70, and you divide that and you get 0.006 straight away. So K is 0.006, however you slice it. Part C. We'll do part C over here, part B. It says estimate the heart mass of a person with 60 kilograms, because now you have the formula. We now know that Q is going to be KT, and we now know what K is. And by the way, that constant is the same constant throughout the problem. So it's a rate. So it's O is 0.006, like we saw in the last example in the last video. So now I could take Q equals, they wanted when the person's body mass, which is the T, so you're going to say 0.006 body mass is 60, and you can actually plugging in the T, you can find the Q. Multiplying these two on your calculator, you should get 0.36. By the way, this was the T, so it was in kilograms. And this 0.36, believe it or not, is going to be in kilograms. They have to be consistent. So that would be the answer to part B. This K is a constant that absorbs whatever units you need to convert from one to the other. So that is example 5. Going on to the next page. So let's look at example 6. Which graphs are proportional? So we saw a graph, first of all, is going to be proportional if the rates are the same. So you need it to be a line. So C is not going to be proportional. We can check it out. So this is going to be a no. And you're going to also need it to go through the origin. So because part B doesn't go through the origin is right there. Here's the origin here. This is going to be a no. So the only one that's yes is part A. And you don't have to take my word for it. We can check it out. So let's go ahead and check it out. Let's make a chart here, X and Y. So here when, see what's a nice easy one. When X is 6, Y is 15. What other one do we have there? There's no other points that are really good here to test this out, I realize. So let's just look at 2, because we're going to break this up 1, 2. So when X is 2, it looks like the Y is 5. And if I take 15, look at my proportionality. So I'm going to take Y divided by X and see if it's a constant. So this would be 15 over 6, which if you divide by 3, you would get 5. Divide this one by 3, you would get 2. I guess I'll show that. I'll just write that. Divide by 3. Sorry, 3. Divide by 3, you would get 5 over 2, which is the same as the other one. So every time you divide, you get the same constant, so it's proportional. Notice how 0 over 0, you can't test 0 over 0 because 0 over 0 is undetermined, but it does go through the origin. You could see this one does not work because if we test, let's see, what's this point? 1, 2, 3. So it looks like it's the point 1 is 2. That's 1, 2, 3. And 2 is 3. So if we look at Y over X, that would be 2 over 1, which does not equal 3 over 2. So you can see that for it to work, it really does need to start at 0, 0. Even though 0, 0 does not make sense, is undetermined, but you can see 0 was 1 here. It did not go through the origin. There's that point there. And the last one shows that you need to have a line. So let's look at this one, X and Y. So this looks like the point 1 is 1, and 2 looks like it's 4. It does go through the origin, so that's good, but it's still not proportional because if we look at 1 over 1, that does not equal 4 over 2. And the reason this is because it's climbing at a faster rate here. So we're looking at the rates, and the rate for the second one is faster than the third. So what we're looking for, lines that go through the origin. Things are proportional are lines that go through the origin. We need the word the. That's what we're looking for proportionality. Oh, by the way, I did find the constant. I didn't read the second part. Find the constant of proportionality. If it is a yes, and it was part A was the only one, and we found it. It was 5 over 2. So let's look at exercise 1. You can go ahead and try it. If you want to pause here and try exercise 1 and come back when you're ready. If R is proportional to S, then the formula is instead of Q equals KT, I'm going to call R goes alone, and it's equal to some KS. Or you could write it as R over S better equal to a constant. You can find R. Well, I'm going to first find K. So step 1, I'm going to find K. So how do you find K? I'm going to take the second one. I'm going to look at the K we know is R over S. So when you have 36 over 4 is k, so that would be 9. K would be 9. So you now have the formula R is equal to 9s. Step 2, then I can answer the question. Find R when S is 5. So to find R, I now have the formula 9s. I can put a 5 in there. So R equals, actually I do it right here, 9 times 5, or R is 45. So that's how you would find a value. So again, I still find the K, and then I plug in the K and what they're giving me to find the R. Okay, you can try this one. Again, pause it. Last one. See if you can do the same thing. And you're ready. Come back for the solution. So it says here that the distance m in inches, so I wrote m is the distance in inches, between 2 points on the map is proportional to the, there's that word again, the actual distance d in miles. So I wrote d is the distance in miles. So since m, so m comes first, so it's m equals k times the d is in miles. Or we can write it as k is equal to m over d. Part A says if 1/2 represents inch, so that would be 1/2 inch, that would be 1/2 here, represents 5 miles, that would be 5 here, I can find the constant. You know, actually, this one would be fine, but that's a double fraction. That might be a little hard to deal with. So you might even want to do it here. I'll show you that one in a minute, but this one is the m is the 1/2, the k we don't know, and the distance is 5. So we have 5k is 0.5. You divide both sides by 0.5, or sorry, divide both sides by 5. I think you get 0.1 on your calculator. That might be a little easier. But you could do this as well, because you can multiply top and bottom by 2, for instance, or just take 0.5 divided by 5, right? But multiply top and bottom by 2, and you get 1/10. That would give it to you in a fraction, which is the same thing, because 1/10 is the same as 0.1. So we know k, or you can say, if you'd rather a fraction, k is equal to 1/10. Great. Part B, so you have the formula now. M is equal to k times d. So if you use the first one, you could say 0.1 d, or if you'd rather, you could say the second one, 1/10 d, either one. This one is the same as d over 10, so you have that choice as well. How far apart are the two towns if the distance between them on the map is about 3.23 inches? So now I'm just going to go ahead and use that first one. Might as well just go for a decimal. We have m and d. Again, m is in inches. I know it should be miles for m, but it's not. D is in miles. So it says 3.23 inches is this way. This is this one. It's asking what is the actual distance in miles. So if I come here and put in a 3.235 here, times d, I can divide both sides by 0.1, and we get 32.5 if you did that on your calculator. So this means in miles, so it's 32.5 miles away, or the distance between the two towns is 32.5 miles. And that concludes our videos for this section.